All right, guys, welcome to this video. This is going to be part 2 of what topics to focus on for AQA A-level Chemistry. Okay, paper 2 is coming up. Here we go. So I'm actually super proud of how this video turned out. Most of you guys are probably here from my paper 1 analysis. This is going to be that style of video, but just juiced up to the max on steroids, right? I know I'm kind of tooting my own horn here, but I think this is probably one of the best paper 2 revision resources for AQA that you're ever going to find. Okay, it's going to have every single question right here broken down for you and where you need to focus your revision. So if you haven't seen paper 1 analysis, no worries. Let me just go through this and what this video is going to be about. So as you guys are probably on study leave right now or going through your revision, you know that your revision time is precious, all right? There's only 24 hours in a day, and hopefully at least a small portion of that is taken up with sleep, right? And you need to be able to divide your revision time carefully, okay, between your other subjects. So some of you guys may have finished psychology and you got maths to go or something like that, right? Biology. But chemistry does take up a ton of time. There's an insane amount of content and understanding involved. Now, the next point here is you need to remember that papers are incredibly similar year after year, okay? There's only a limited amount of style questions that it can ask you, and they have to pick and choose and recycle them based on the topics that are included in each paper, okay? So, which topics should you focus on to improve your chances of getting an A or an A star? Now, use this video as guidance only. If at all possible, use the entire specification, all right? It's always good to cover all bases, but the whole point of this video is to recognize patterns and use some sort of data analysis to look at whether there are themes of certain topics occurring more frequently. So that's what this video is going to be all about. So there's going to be 4 sections to this, right? Section 1 is going to be what topics from the AQA specification are in paper 2. So I'm going to break down and look at all the topics you need to be aware of from the specification. Then we're going to look at a paper by paper breakdown for all the topics that are allocated marks for paper 2. If you're a bit confused, no worries, I'll jump to that in a bit. Next up, we're going to look at the topic mark allocation summary and averages for all 6 papers, okay? So 2017 to 2022, and what should you primarily focus on? And then, guys, this is the part that took me the most time, okay? I'm going to give you a brief description of every single question from the past papers broken down by topic, okay? I'm going to say what the question was referring to in a brief summary, and then I'm going to say what question that was and which paper it is, so you can really pinpoint precision your revision and go to the questions that you need to focus on for each respective topic. Right, so this on the screen right here is paper 2 topics, okay? AQA A-level Chem specification. So you have the physical topics on the left here. Then underneath that, you have the required practicals that you have to be aware of. Now, the bulk of these practicals are going to come into play for paper 3, okay? So there's 12 required practicals, but you do need to be aware of and have little bits of knowledge for these specific required practicals that I've listed on the screen right here. The table on the right-hand side, we have every single organic topic, okay? So before I start, again, caveats, right? So this is really, really important. Something I want to mention regarding the methodology of my analysis and some logic behind it, okay? When I mention organic analysis as a topic, this can include NMR, okay? It's really difficult to divide some of these organic analysis questions, since a lot of the analysis questions will actually include a combination of IR, NMR, and sometimes also mass spec, okay? So keep that in mind. But at the end, when I summarize all of the questions broken down by topic, you can check out which ones include IR or NMR and also practice those as well if you need to do some extra NMR revision. All right, so this was actually hard to break down, okay? For paper 2 specifically, it's not as clear cut as paper 1. There is a lot of synoptic knowledge, okay? So it goes over the entire specification and they sort of slot multiple topics together. So for example, one 4-mark question can be a mixture of 2 or more topics, okay? It might have a bit of esters chucked in there, a bit of carboxylic acids, a bit of aldehydes. You know, it can be a variety of things, especially when it comes onto certain like isomer or analysis questions. There's all sorts of different functional groups. So it's really hard to separate those topics, but I've done my best. All right, guys, this is where we jump into the actual analysis, paper by paper breakdown. So if you've seen paper 1, you'll be well familiar with what this chart demonstrates. But if you haven't, I'll go over it briefly for you. So we have a chart here, right? Nice colorful chart. X-axis right here. This is just the topic that was present in the paper, right? So pretty simple there. Then the y-axis is just the marks allocated to the paper. So again, similar to paper 1, 11 marks was allocated to rate equations out of a potential 105 marks for the entire paper. Okay, now up here we have our UMS. So hopefully you're aware of these grade boundary values here. A star, for example, for paper 2 2017 was 86 marks. I think in general, actually, paper 2 seems to be harder than paper 1. So normally the grade boundaries are a little bit lower. And then A was 72 marks, B was 59 marks, etc. Okay, gradually drops down as we go. And again, this is out of a potential 105 marks. So like I said in my paper 1 video, guys, you don't have to be perfect. Paper 1 was yesterday. I've had a bunch of people message me stressing out, freaking out, thinking they failed and it's the end of the world. Just remember, you can lose marks and still get a really good grade. So just be optimistic. Try your best, revise for paper 2 and 3, and it will be completely fine. So what else is included in this chart right here? Let me rub this out. This dashed box right here, what does this tell us? Now, this is the baseline that I chose. You'll be familiar with this from paper 1. The baseline is how many topics are included or must you maximize your marks on to get an A. Okay, and that is what my baseline is. Some people may be going for a B, some people may be going for an A star if you're going for medicine at a really good uni or whatever it may be. But I think A is really solid ground for most people, okay? So I've included that as my baseline. If you want to get an A star again, you bump it up a little bit, okay? Include some extra topics here. If you want to go for a B and you're happy with a B, bump it down a couple topics, okay? All of the marks that are allocated to each topic are above these columns right here. So you can do the maths yourself and work out what you need. Now, another thing I want to mention is, like I said a bit earlier in the video actually, is paper 2 varied a lot more than paper 1 in terms of the spread of topics and the spread of marks. So at the summary, at the end, once we've gone through each individual paper, you will see there is still favoritism or themes that represent certain topics popping up more often than others, but we'll look at that in a little bit, but just keep that in mind when we're going through the individual papers. So what do we have here, guys? Rate equations was the highest here, then it was organic analysis, then halogenoalkanes or haloalkanes, however you want to say that, aldehydes and ketones, amines, amino acids, proteins, and DNA. So next one here, 8 marks, amount of substance, okay? This is fundamental and it does come up a lot, okay? Even though it's a physical chemistry sort of calculation topic, comes up in paper 2 all the time, okay? And it applies fundamental knowledge to other calculation topics like KC, and we've got rate equations right here. There's a lot of calculations in rate equations, okay? So just keep that in mind. Then next up we have chromatography. So this is its own topic, normally thin layer chromatography right at the end here. And then obviously this is both 7 marks here, so you could just change those up, whether you want to focus on chromatography or carboxylic acids and derivatives. Now, I personally would focus on this. This is far more common than chromatography, okay? I think off the top of my head, chromatography has only come up in 2 papers so far, but it may come up this year, okay? I think the last time it was in 2019, so it may pop up. You never know. Okay, this isn't a prediction video. I'm not telling the future, I'm just going off of patterns and analysis. So let's look at paper 2 2018. All right, cool. Again, you're going to see a theme here actually, guys, and this surprised me so much, how many marks are allocated to rate equations. And I think the primary reason for this is because it's actually a physical chemistry topic, but it's completely absent from paper 1. So they've chucked that entire topic into paper 2. So just keep that in mind. This would be one that I would say 100% focus on. Okay. Next one, chemical equilibria KC. Again, a physical topic, okay, but it does make up a very chunky amount of paper two, so just keep that in mind. Next up, aromatics, okay, they love aromatics in paper two. We have alcohols, amino acids, proteins, and DNA, and amines, okay. Again, these are both 10 marks, so these are interchangeable, amines and alkanes. Just switch them up for this paper and you'll be good to go. What were the grade boundaries this year? A star was 84, an A was 69, and a B was 57. So you can see here 71 marks, although that's slightly above an A. That just includes all of these topics right here. Okay, just added together. It's that simple. It doesn't get any more complicated in terms of these charts, all right? Let's look at paper 2 2019. All right. Amount of substance went absolutely ham on this one, all right? 18 marks, all right? 18 marks, paper 2, 2019. Let's see what's going on here. We also have organic analysis. This was a chunky monkey right here. Then we have amines, rate equations, aldehydes and ketones, organic synth, and polymers. All right, and then also interchangeable right here is NMR. I personally recommend picking NMR over polymers any day of the week, just because it has a higher mark spread or mark allocation in general, and it's just a more difficult topic, so they're more likely to include it in the paper, right? That's just my perspective, but revise whatever you can, to be honest. Next up here, grade boundaries. A star was 86, A was 72, and B was 59. Now, I'm not saying, like, for example, like I don't name these ones right here. It's not saying that I don't care about them or they're not important. It's just that in this respective paper, they didn't come up in the top allocated marks, okay? So just keep that in mind. All right, 2020, paper 2, let's go. Carboxylic acids and derivatives, NMR right here, amount of substance, KC, rate equations, organic synth, okay? And then organic analysis and halogenoalkanes are pretty close here to the 10 marks. One thing I will say, guys, organic synthesis. So I've included organic synthesis as its own topic because it involves those, you know, like 4-step reaction schemes that you have to solve with all the reagents and conditions. I've done a pretty in-depth video on my channel about how to solve these, but these involve content from every single functional group topic, essentially, okay? So even though it's its own topic, it does include content from a variety of these topics, okay? So just keep that in mind for this sort of topic right here, organic synth. What were our grade boundaries? A star 82, A was 66, and a B was 54 marks, all right? You can lose 50 marks, like pretty much half the paper, and still get a B, okay? So if you're going for a B, don't stress out. It's not too bad. And then an A is only like 10 marks higher than that, okay? So don't, what I want to emphasize to you guys is, because I've had so many messages, don't stress out, don't freak out, okay? Just be positive, do your best for your revision, and you'll be completely fine. All right, 2021, what do we have here? Organic synth was really big this year, okay? They do love organic synthesis, so just keep that in mind. Then we have alkanes, rate equations, amount of substance, aromatics, NMR, energetics, and then here's interchangeable with KC. Okay, I would 1,000,000% go with KC over energetics. You'll see that later in the summary, how many marks energetics received overall. It's not that high, okay? So the way, this is my perspective, AQA, because energetics is a year 1 topic and thermodynamics is a year 2 topic, thermodynamics is their favorite because it's so much more complicated and difficult and has more content in it, right? Born-Haber, all your different enthalpy calculations, entropy, Gibbs free energy, all that good stuff. So what they do is they funnel and chuck all of that into paper 1, and then there's like trickles of energetics in paper 2. Okay, so don't freak about that too much. That would be my perspective there. And then we have all these ones right here. So feel free to pause the video this whole time, just look what's present. Alkenes was struggling this paper, only 2 marks here, not too bad. All right, A star 82, A was 67, B was 55. All right, cool. Let's move on to 2022, the final paper here. All right, guys, as we see, alkenes had a comeback. Hey, look, 2 marks in 2021. He's like, you know what, mate? 19 marks in 2022. Yeah, AQA is just like, I don't know, man. They flip their stuff around. But we're going to look at trends. We're going to look at patterns, and hopefully it helps you focus your revision. Next up, with amount of substance. I'm still laughing about this. It went from 2 marks to 19. That is just mental. Amount of substance is 13. Rate equations 13. Carboxylic acids and derivatives is 9. Then we have KC is also 9. Amino acids is also 9. And then it dips down a little bit down here. All right. What was an A star this year? 84. A was 70 and B was 56. Now, the primary reason that alkenes was so high here was due to some required practical stuff for paper 2, but we'll look at that a bit later. All right, guys, I'm going to go into the summary chart. And yeah, this made me laugh when I first saw it, okay? Maybe you're not going to be surprised, but I was surprised, okay? So let's see what the highest marks are across all 6 papers over 2017 to 2022. They're all physical topics, guys. I thought this was so ironic considering everyone thinks of paper 2 as organics. Now, obviously, collectively, this makes up more marks from the organic side of things, but our 3 highest topics that you really, really need to focus on, and this pinpoints your revision perfectly from the physical side of things. Rate equations got 71 marks, amount of substance is 60 marks, and chemical equilibria KC, 49 marks, all right? So hopefully, I was super surprised, but hopefully this helps you guys out and you realize where you need to focus on for the physical side of things. Now, what happens here is there were some more things present after halogenoalkanes, okay, but it slowly trailed off, tapered off, so I haven't included it. Things like chromatography, polymers. I think the polymers was the next one and that only had 12 marks out of all 6 years. So I just left it off, okay? So these are going to be the ones that I'm focusing on. So where's the highest marks from organics? Synthesis, okay? Organic synthesis. The reason that this has so many marks is because they're normally those 4-step reaction schemes with lots of questions. A lot of memory, guys. I'm not going to lie to you. Memory and process of elimination. If you haven't watched my video on organic synth, go check it out. It's hopefully helped you out. Then we have carboxylic acids and derivatives. Okay, the reason that this one is so big is because it has so many functional groups in it, right? It has carboxylic acids, esters, all the ester reactions. Then it has acid anhydrides, acyl chlorides, and all the mechanisms, reagents, reactions that occurs with that. Then it has a bit on amides, okay? So there's a lot of stuff going on for this topic. That's why it has so many marks. Then we have organic analysis. Now, this is very common as well, and it involves a variety of things, really. So it involves infrared spec quite a lot of the time, and it involves NMR sometimes as well. That's what I've included under this topic, just because, like I said previously in this video, there's a lot of combination questions where it has a mixture of IR and NMR, and then sometimes a bit of mass spec thrown in, and you have to solve the structures and all that sort of stuff. So that's why it has quite a lot of marks here. So I'd focus on that one if you can. I've done a very in-depth breakdown of solving IR and NMR questions and my thought process behind that. Then we have amino acids, proteins, and DNA. I think this has come up in every single paper. We'll look at a second when we look at our summary table of its frequency, but I definitely revised this one. NMR is next, okay? NMR is 38 marks here, but as I said, there is NMR content in organic analysis. So make sure you know this guy right here. It's quite a complicated topic. It's very time consuming. So I personally, when I did my exams, I left these questions for the end just because the return on investment in terms of the time you spend to solve the questions is not always really worth the marks that you get, okay? But that's my perspective. Don't switch up how you do the past papers, okay? Do what you've been doing. Do what works for you. Then we have amines, okay? Amines is quite a broad topic. There's a lot of marks there. Aromatic chemistry, I would definitely go for this. It's not a difficult topic, okay? There's only 2 mechanisms you need to know for electrophilic substitution. You've got nitration, Friedel-Crafts acylation. Learn those 2, learn the catalyst, learn the equations. It's not that complicated. And then you have some knowledge of benzene that you need to understand regarding enthalpy and bonding and all that stuff. And there's a couple other things you need to know, okay? But it's not that hard of a topic. And AQA absolutely loves this topic for organic synthesis, okay? They often have some sort of benzene or aromatic molecule present in the organic synthesis pathway, even if the reactions don't involve it, okay? So often it will start as a benzene or it will simply be a substituent phenyl group. Okay, so just keep that in mind. They chuck it in to freak you out, but in reality, it's the other functional groups that are attached to the phenyl group that are reacting. So just keep that in mind. Okay, then we have aldehydes and ketones. This is a good one to learn. Again, nucleophilic addition is a lot of the marks for this one. Then we have alkenes, alkanes, alcohols, and halogenoalkanes or haloalkanes. These are year 1 content. Okay, so they're not as chunky as you'll see here. The majority of their marks are for year 2 content just because it's more difficult. That's just how things are going to be really for AQA, and I'm assuming other exam boards. I haven't done these analysis videos for OCR or Edexcel or anything like that, but I'm assuming they're quite similar in terms of their structure of prioritizing year 2 content because it's more difficult. All right, here we are, juicy stuff before we move on to the paper breakdown. So in my paper 1 video, right, I ordered it based on the average marks per paper based on paper frequency. I have decided to change that this time and order it based on total marks just to put that into perspective. Whereas I've also included the paper frequency so you can see how many times it comes up. All right, obviously 6 is the highest possible value here because there's only been 6 papers from 2017 to 2022. So I personally, if I was revising this in your shoes, I would focus 100% on the topics that have come up every single time. That would be my main focus because in all likelihood, they're going to come up this year, right? They may not. It's not always perfect. AQA can sort of do whatever the hell they want. And then I would jump down to which ones have occurred 5 times. And then I would condense my revision down further as we go. All right. But as I said, these 3 boys right here, rate equations, amount of substance and chemical equilibria KC, Le Chatelier, all that good stuff. That is the physical ones I would focus on. And then I would move on to organic synth, carboxylic acids and derivatives, bit of NMR going on here. As you can see, NMR is in every single paper. Now, technically, it only came up 5 times, but I've included it 6 times because it came from organic analysis. Okay, so this 6.3 might be a bit skewed, but just keep that in mind. What do we have here? Alkenes as well. Low marks here, only 29 because again, it's a year 1 AS topic. So there's going to be less marks up for grabs. And then down here, we just have basic stuff, alcohols, halogenoalkanes, all that stuff, right? So these 2 actually didn't come up that much, which was quite surprising to me. But yeah, pause the video, take this table, use it however the hell you want, but this is the data. There we go. All right, guys, this took me ages, okay? So this took me such a long time. So if you are finding this video helpful to pinpoint and focus your revision, give me a like, share it with your mates. It really helps out the channel. So I'm going to go through the topics step by step, starting with alcohols here, breaking down a brief description of what the question was about. And then I'm going to link you to where the question is. So this one, for example, was from question 3 2018. This one was also from question 3 2018. This is question 2 2019, etc. Okay, hopefully you get the idea here. So you can either pause this yourself and read through this, right? And then go to the AQA website and do the past papers, check out the mark schemes, okay? Really pay attention to the wording in the mark schemes. I cannot emphasize this enough. Or I'm going to read through it as well. So if you just want to let the video play, that's fine. The timestamps will be down below so you can skip through the different topics, come back to this video and fine tune your revision and go over specific topics that you're struggling with or you just don't understand. Right, so alcohols didn't come up too much. As I said, it was a year 1 topic. So this question 3 right here, this involved intermolecular forces of alcohol oxidation products. How we maximize the yield of an aldehyde, and some test tube observations. I'm not going to go into crazy detail, as I mentioned. Please just check out the question yourself. Otherwise, this video would be way too long, but this is the summary of what to include, so it sort of allows you to know what you need to know from previous questions, right? Next up, we have acid catalyzed elimination mechanism. This has only come up once, but yeah, there we are, 2018. Then we have required practical 5 knowledge, okay? What was included here? You needed to complete a distillation diagram. So you do need to be able to complete diagrams, ideally in pencil, right? You need to know what you need to include from the mark scheme. Just check that out yourself. It also involves stating why cyclohexene can be separated from the aqueous solution using a separating funnel, okay? And you need to give observations to confirm that the cyclohexene was dry. Okay, next one we have here was a 6-mark level of response question to do with bioethanol. You need to outline how bioethanol is produced. You had to give the relevant equations for this, and you had to analyze the environmental impacts. Okay, so that was everything for alcohols. Let's move on to aldehydes and ketones. Right, this one was a bit more chunky here. A lot of nomenclature. Okay, so brush up on your IUPAC naming systems, how you name aldehydes and ketones, and their respective mechanism products. As you can see here, guys, a lot of IUPAC nomenclature. Okay, you need to be able to name the aldehydes, the ketones, and their respective mechanism products. Okay, so for example, this first one here, you need to be able to name a hydroxynitrile product. All right, and then it followed up with some optical isomerism questions. For example, how you would distinguish one optical isomer from the other. All right, just some stuff there. Another IUPAC nomenclature question, and then we had reagent and name of a mechanism. Another naming question right here from 2019 this time. And then this question right here involved nucleophilic addition mechanism. You had to be able to explain why sodium tetrahydroborate reduces aldehydes but not alkenes. And then we had a chemical test reagent and observation for aldehyde. So the one I'd go with is Tollens. I'm not going to go through the answers in this one. This is just the questions, but yeah, juicy tip there, Tollens reagent. Next up, nucleophilic addition mechanism again. Okay, this is very common, nucleophilic addition. And then we had to be able to suggest why a different nucleophilic addition reaction is slower. And this regards electron donating alkyl groups, okay, methyl groups, stuff like that. So just keep that in mind. And you have to be able to draw the skeletal formula of optically active isomer and then describe how to distinguish between these two enantiomers. Okay, so very similar to this question right here, sort of repeating itself really, but with some skeletal stuff thrown in. And then we have nucleophilic addition again, all right? So try and learn that mechanism. I have a video that goes through every single curly arrow mechanism you need to know for paper 2. So feel free to check that out or whatever video you want to watch on it, but try and learn those mechanisms the best you can. All right, alkanes here, another year 1 topic. Combustion equations, catalytic cracking, free radical sub-equations, radical identification, and explanation of ozone decomposition. All right, this was from 2018. And then we have a combustion equation. Now, this was technically combustion of an ester, so a bit of synoptic knowledge here, but it was knowledge of combustion from alkane topics specifically, so that's why I included it here. Next up from 2021, we had crude oil fraction, cracking equations, and catalysts, and giving a reason why CO2 absorbs infrared radiation. Now, this right here is technically from organic analysis, all right, from infrared spec, that sort of knowledge. But I included it here bunched up with the remainder of question 2 questions because I thought CO2 kind of fits in with global warming and all that stuff you learn for alkanes. So I included it here. Just keep that in mind. All right, next up, why is the ozone layer beneficial to living organisms? How CFCs form from chlorine. You need to do 2 equations for the decomposition of ozone. Okay, flashcard special, just remember that one, guys, if you have time, by chlorine atoms specifically. And then equations for free radical substitution, naming a specific step. So for example, in this one, it asks for the propagation equations. You may need to write the initiation or termination depending on what's going on. And then lastly here, we have the environmental problem of CFCs and why alkanes do not cause this problem, okay? So a lot of alkane topic is to do with global warming and environmental damage and stuff like that. So just keep that in mind. Right, alkenes here. IUPAC naming, again, like I said, even though naming or nomenclature specifically comes up under Introduction to Organic Chemistry, I tried to slot them under their respective functional groups where they're being named by. Okay, so this was an alkene isomer, and you had to be able to name that. Next up, again, naming an isomer and explaining EZ isomerism. So again, isomerism, I'm pretty sure is under the Introduction to Organic Chemistry topic. But when it's relevant to a specific functional group, for example, EZ is very alkene heavy. Actually, it's pretty much just alkenes. That's why I've included it here, okay? So electrophilic addition right here, normally like a 5-mark mechanism question, something like that. So if you do memorize these, they're not that difficult, and you can just snag yourself 5 marks if it does come up. This one right here, drawing the remainder of a skeletal formula of a Z isomer. Okay, so do learn your skeletal formulas. Some people find it tricky, but it does come up quite a bit. So just keep that in mind. It's not the end of the world. It's only scattered out odd papers, but it does come up. So, it's useful to know because it's not that difficult. Next up, drawing E and Z isomers that show both geometric and optical isomerism. So this was an interesting one, really, bit of synoptic optical isomerism thrown in, but because it was an alkene EZ isomer, I chucked it under this topic. So essentially, it's going to have a CC double bond, and then there's going to be some sort of chiral activity on one of the side groups here. Okay, so I'm not going to go through the answers again, but that's just explaining that briefly. Next one here, guys, electrophilic addition mechanism again. And you have to be able to draw and explain the minor and major product. Okay, this is a useful theory to understand. I've gone through this on past paper videos before. Drawing functional group isomers of alkenes, drawing the repeating unit of addition polymer, and naming the type of polymerization. So this pops up again in the polymers topic for year 2, but this was an alkene specific topic and it's also present in alkenes as well. So I included that here. And then we had a required practical 10 question from 2022. I haven't included the specifics here, but it was just a variety of 1 to 2 mark questions related to a method. So that's very common in paper 2. They'll give you a specific method for a practical and they'll ask you a variety of suggest and justify questions for that, okay? Very difficult to break down. It can vary quite a bit. So just keep that in mind. All right, amines. There's multiple slides for this amines one right here because it's quite a chunky topic. First off, skeletal formula of a tertiary amine. So it wanted you to draw that. Next up, you need to talk about the order of increasing base strength of amines. Okay, this one's fairly common as well amongst the amine topic, I mean. And then you had to be able to identify different amines in 3 infrared specs. Okay, so again, slightly bit of organic analysis. As you can see here, synoptic stuff, they throw stuff together. It's difficult to separate, but because it was specific amine knowledge and amine functional groups, I included it here, okay? Again, skeletal formula, okay? Skeletal formula for 3 secondary amines. You had to justify the preparation of primary amines from nitriles and why this is better. You had to draw the structure of a primary amine that cannot be formed by a nitrile. These are all specific examples, so it won't be like a primary amine can never be formed from a nitrile. It was very question specific, so if you're a bit confused, check out the question. You had to write the equation and the observation for propyl amine plus water. You had to write the equation and the explanation for the reduction of nitrobenzene to form phenylamine and why aqueous solution is obtained even though phenylamine is insoluble in water. All right, amines 2, guys. All of these right here was from question 1, 2019. So you had to do an equation for the preparation of an amine with excess ammonia, all right? Then we had mechanism for the formation of an amine right here. So this could, I guess, come under nucleophilic substitution of halogenoalkanes, but I included it under amines here because it was in an amine question and it sort of felt silly to split it up. And then right here, you need to write the reagent and the conditions of 2 stages, okay? 2 stages in an organic synthesis reaction. You had to write the reagent and conditions of 2 different stages for that. You had to be able to explain the base strength difference of ammonia and amine. So again, guys, base strength difference, this is quite common. Okay, this is in the amines topic. And then you had a question about chiral centers in an amine, just identifying them if I remember correctly. And then you had to complete a mechanism here, IUPAC naming of a product. I can't remember, I'm assuming it's a product. And you had to deduce the role of the reagent. Okay, a specific reagent here. Can't remember which one it was, but check out question 2, 2021. And you had to be able to explain the differences in the yield of 2 amines based on 2 different reactions. And you had to explain the difference in base strength. Again, difference in base strength. Okay, this is pretty common here. Not too complicated to understand. I would memorize this if at all possible. But yeah, question 10, 2022. I know some of you don't have access to 2022. So just try and comment down below if anyone can send it to you. I'm not too sure, but I can't actually post it because it hasn't been officially released. So just keep that in mind. All right, amino acids, proteins, and DNA. So there's a lot of memory here, okay? for amino acids, proteins, and DNA, and a lot of sort of like diagram solving and diagram drawing and stuff like that. So it's a bit complicated for people, especially if you don't do biology. So let's look at what was included here. You had to be able to draw Zwitter ions. Okay, this is pretty common here. And draw amino acids at different pH, and also be able to draw dipeptides. Okay. Next up, you have to be able to name and draw DNA groups. So you're given a data booklet, right? And there's some DNA and amino acid stuff in there, so get well familiar with that, okay? Next up, you have to be able to explain hydrogen bonds in polypeptides. You have to draw a disulfide bridge between two cysteines. This is pretty common in terms of amino acids. They like to test your knowledge of this covalent disulfide bridge and the strength of that. Naming types of proteins, so saying whether something's primary, secondary, tertiary, etc. Drawing Zwitter ions again. Okay, next up, complementary bases in DNA, working out the number of hydrogen bonds between bases in a strand of DNA, and completing a diagram for 2-deoxyribose of DNA. Okay, this is a very DNA-heavy question right here. Next up, drawing some hydrogen bonds between DNA strands, drawing rings around each component of a nucleotide, so you've got to separate into the specific components, and state the meaning of the term complementary in reference to sections of DNA. Right, part 2 for amino acids, proteins, and DNA. Again, drawing, there's a lot of drawing in this topic, not going to lie. Drawing circle around a chiral center, so hopefully you're familiar with what that is. Identifying functional groups, so an amine and an amide. So you have amine, NH, and then whatever H's are on it, and then amide is obviously like this. Okay, and the O can be up or below. But just recognize those functional groups. You needed to be able to identify which ones are present. Drawing structures of hydrolysis in acidic conditions, and explaining how structural features of an enzyme enable it to catalyze the hydrolysis of one optical isomer, but not the other. Okay. Next up, again, a type of protein question. So you just need to understand the basics of whether something's primary, secondary, tertiary. Next up, you have to be able to draw a section of a protein from a data booklet. Naming the other substance formed when two amino acids join. This is always water. Okay, just try and remember that. Explaining strength differences of different R group interactions. Deducing the type of interaction between specific R groups. So this is quite common here. Understanding of R groups and how they interact based on their bonding and intermolecular forces, stuff like that. Let's move on to amount of substance, okay? Amount of substance is one I 100% recommend because it sort of just carries over from paper 1, right? So it's just a bit more revision, get that fresh in your mind and do some calculations. So here, I didn't go into great detail in terms of like what the question asked for, but it's a variety of marks ranging from like, I don't know, 3 to 6 marks. Okay, not actually, maybe 6 is a bit high. 3 to 5 marks most likely, okay, for these amount of substance questions. Some might get even higher, actually. I'm not going to lie, I can't remember. But question 1, 2017 was to do with a mass calculation. Question 10, 2017 was ideal gas equation calculation. These are a bit more weird and nuanced than paper 1, I'd say. Question 2, 2019, percentage yield calculation. This involved a density calculation. Okay, so you know how to calculate density. They always give you the unit, so you can just calculate it from the units, to be honest, the equation there. I have a video that goes through every single amount of substance equation you need to know, so if you're a bit baffed, check that out. Next one, molecular formula calculation. Question 3, 2019. Another mass calculation here in 2019 again. Next up, molecular formula calculation. So this is pretty common as well. So hopefully year 1 topic right here, just working out what the molecular or empirical formulas are. That's right there. And then a mass calculation involving some sort of titration right here. Okay. Next up, another mass calculation. They love these mass calculations in paper 2. And then identifying the reagent in excess. Okay, so I've done an amount of substance video regarding limiting and excess reagents, so feel free to check that out. All right, part 2 here for amount of substance, hydrated salt calculation and empirical formula. So I've had a bunch of people message me about a hydrated salt calculation from paper 1, 2023. Apparently it was pretty savage, but I haven't seen it, so I'm not too sure, but hopefully you guys were okay with that. And then, as I said, empirical formula. Okay, so this is pretty common, working out empirical molecular formulae. And then we had to calculate a value of N amongst this. So general formula here, and you're given the MR value. So check out the paper if you're a bit confused. Try and memorize that methodology, but it's only come up once really, so it's not too important, to be honest. Next one here, percentage by mass calculation. So try and learn that. Mass calculation given a yield, and this includes density calculation again. Uncertainty question, so a bit of practical stuff here, but this is included. So uncertainty is included under amount of substance, okay? Then you have a mole calculation, a mass calculation from percentage by mass, and then deducing the molecular formula. So again, molecular formula, guys, brush up on this as well as empirical, and you should be good to go. Right, guys, aromatics, okay, good old benzene. What do we have here? Equation and the mechanism of nitration. So this is an electrophilic substitution mechanism. Like I said, guys, at the beginning of the video or earlier on, try and remember these electrophilic substitution mechanisms. They're honestly not that hard. Memorize the equations and the electrophiles, all that stuff, and you'll be good to go. Next up, explain the bonding in benzene, okay? The enthalpy of hydrogenation of cyclohexa-1,3-diene compared with cyclohexene. Okay, this came up in 2018. So brush up on the enthalpy side of things for the aromatics. Next up, Friedel-Crafts acylation. This is just another type of electrophilic substitution, okay? Another mechanism for that. And again, equation for forming the electrophile. Okay, catalyst as well. Memorize the catalyst. Next up, calculating the enthalpy change of benzene from data table and an enthalpy diagram, explaining in terms of bonding why benzene is more stable thermodynamically. I put stable twice here, but ignore that. Than the Kekulé structure. Electrophilic substitution mechanisms. Okay, so this is a pretty chunky aromatics question. The enthalpy diagram. So where did I put it here? Did I write enthalpy diagram? Yeah, I did. Okay, cool. Enthalpy diagram. This was a weird one because it's the first time I've seen this, so it may have thrown a few of you off, but it's very similar to a Born Harbor. Okay, year one, you learned about enthalpy diagrams, but hopefully you're all okay with that. If not, check it out. Check out the mark scheme, question 4, 2021. Bit of a weird one. Don't really expect it to come up again anytime soon, but you never know. Next one, we have equation for the reaction of benzene with acyl chloride. So this is just Friedel-Crafts acylation and naming the product. Identify the catalyst in the Friedel-Crafts acylation, and an equation for the formation of the electrophile, outlining the electrophilic substitution mechanism. So a lot of electrophilic substitution mechanism, drawing it out, catalyst, equations, all that good stuff. So I'm not going to go over this anymore. But yeah, brush up on aromatics because it also comes up in organic synthesis, okay? Bonding, this guy's real lonely here, question 2, 2021. The reason that it's only one question is because honestly, there was only one question, I'm not going to lie to you. It was drawing two shapes and stating the bond angle and explaining whether a bond angle is greater, the same, or smaller between two different molecules. Okay, so if you're curious about that one, check it out. But as far as I could tell, this was the only bonding question. All right. All right, this is where we get into a very, very long topic. Carboxylic acids and derivatives. There's a lot going on here. What do we have to do? You have to be able to draw a diester, okay? Acyl chloride nucleophilic addition elimination mechanism and naming the product. A very common mechanism for this topic, nucleophilic addition elimination. Obviously, you can only do it with acyl chlorides. They're not going to ask you for acid anhydrides. That's not in the spec. You do need to know the reactions for acid anhydrides, but you're all good when it comes onto the mechanism. Okay, next up, again, another nucleophilic addition elimination mechanism, observation, name the mechanism, and draw the product. What's up here? Equation for the formation of an ester from an acid anhydride. So slightly different here. And the nomenclature right here, IUPAC naming the ester product. So I included it under this topic. Drawing the structure of vegetable oil from a given molecular formulae. Okay, so check out that question if you're a bit confused about vegetable oils. Esterification reactions of different isomers. So this is just an ester topic right here, not too complicated. All right, guys, section 2 here for the carboxylic acids and derivatives. So this one was from question 4, 2020, and it was all practical knowledge for the preparation of aspirin. Okay, from an acid anhydride. So I've got some bullet points here to summarize what the questions were about. Feel free to check it out yourself. But you had to suggest a suitable piece of apparatus for a specific part of the experiment, if I remember correctly. You had to identify a hazard of using conc phosphoric acid. You had to complete the equation for the reaction of salicylic acid with ethanoic anhydride to produce aspirin. So some of you may have done this experiment, this practical in class. Producing aspirin, all right? I remember doing it at uni. I think I didn't do it in class, but yeah, here we go. Then you had to be able to suggest why melting point of the crude aspirin would differ from the melting point of pure aspirin. You had to describe the important precautions when heating a mixture of ethanol and crude aspirin. You had to explain the purpose of adding a small amount of cold ethanol, and you had to describe the difference in appearance between crude and pure aspirin. Okay, so hopefully you can see from these practical based questions, right? There's a lot of like 1 to 2 markers just scattered in that are all suggest, identify, describe, justify, all that sort of stuff. Okay, so you do have to understand brief concepts and understanding regarding the practicals, but I would focus on that for paper 3 more so, to be honest. But yeah, it does come up in paper 2, so just keep that in mind. Right, carboxylic acids and derivatives. As I said, very chunky topic here. So this is the third part to this. What is this disgusting name? So fortunately, you may look at this and be like, what is going on? You only had to name this part, so they named the rest of it for you. But yeah, pretty tricky name if you're not too good at nomenclature. What was up next here? Completing a triester equation, naming the other product, and giving one use of the compound R-cook. So you just have to realize what this is and what it's doing, what a use of this is. Reason why aqueous ethanol is suitable solvent for the reaction of oil with potassium hydroxide, giving safety precautions and justifications. All right, cool. Next up, synoptic mechanism, naming the type of reaction, deducing the role of a reagent, and giving the use of a product. The reason I say that it's a synoptic mechanism is because you don't really deal with ester mechanisms, all right? But they just wanted you to apply your understanding of other carbonyl mechanisms to this one right here and get the marks, right? It wasn't actually too complicated. Feel free to check it out if you do have access to paper 2022. And then lastly here, giving the use of the product, and this was soap, okay? Next up, required practical 10. So 2022, required practical 10 was in the advanced specification list. And it was pretty heavy in this paper, okay? So it was preparation of pure organic liquid. If I remember correctly, this was coconut oil or olive oil, something like that. And you had to suggest extra steps to ensure that the mass is recorded more accurately. And you had to state the reason for inverting the flask several times, okay? So just brush up on that. These practical questions are super difficult to make videos on because they can literally ask like an insane variety of small 1-mark questions. So yeah, just keep that in mind. All right, KC, another physical topic here. As you're going to notice, guys, I've done a bunch of KC questions on my channel. This is super common, okay? Equilibrium mole calculations. I suggest just learning the method of ice tables. I can just release like a 5-minute video on this if you want. It's not too complicated, to be honest. And then you can see they sort of follow the exact same format. So equilibrium mole calculation, which feeds into KC expression, which feeds into a KC calculation. And that's very common. As you can see here, exact same thing happens. Okay, slightly different because we have a conc calculation right here. And then you had to explain a shift. So equilibrium shift based on Le Chatelier principle. But yeah, year 1 stuff here, so not too bad. Again, equilibrium mole calculation using ice tables is my suggested method right here. KC calculation and suggesting why a different KC expression can be written without the concentration of H2O. So this is a question specific one. Okay, so just check out question 9 2020 if you're a bit confused. And then equilibrium concentration calculation right here at the end. Right, 2021. The reason I say weird is because I haven't seen a question like this before, to be honest. And it was an algebraic mole ice table calculation. So feel free to check that one out. I honestly don't expect one to come up like this again, but you never know. And then just a mole calculation from KC. Okay, lastly here, we have equilibrium mole calculation again, feeding into a KC expression again, feeding into a KC calculation where you had to include the units, and then explaining the effect of a change in temperature on the position of equilibrium, normally to do with the yield, right? That's normally what they're concerned with. So hopefully you guys can see from this slide to learn the method of ice tables, how to write out the KC expression and how to rearrange and use that KC expression to do calculations as well as the units. Okay, so just keep that in mind. Got a few videos, check them out if you want, or look at some other YouTube videos. Next up, chromatography. This only came up twice, okay? Thin layer chromatography, some RF calculations, nothing too crazy here, to be honest. If you're a bit confused about chromatography or want to fine tune your understanding of the mark scheme, stuff like that. Check these out. Question 8, 2017 and question 9, 2019. As I said previously, I'm a bit suspicious of this because I'm thinking, okay, the last time it came up was in 2019, so it most likely will come up this year because, 2023, there's quite a gap there, you know what I mean? But I don't want to mislead you guys and predict stuff that doesn't happen, but that's what I'd be thinking if I was in your shoes. All right, energetics, enthalpy of combustion calorimetry calculation. As I said, energetics is not common. All right, they chuck in most of the thermodynamics knowledge into paper 1, and then they just leave some scraps of energetics in paper 2. Okay, but the main thing here that you need to be aware of for paper 2 and paper 3 is required practical 2. Okay, so brush up on that if you can. What are our questions here? Designing a data table for enthalpy of combustion experiment. This is the first time I've seen this in paper 2, the only time I've seen this in paper 2, where you have to design a data table, with the correct columns, units, stuff like that. Next one was the disadvantages of using a glass beaker for the enthalpy experiment. All right, cool. Next one, suggesting why enthalpy of combustion in the experiment is less exothermic than the data book value, and suggest a suitable addition to the apparatus given that will improve the accuracy of the enthalpy value obtained. Okay, so halogenoalkanes, let's go through this. Nucleophilic sub, mechanism and condition, elimination mechanism, reagent, condition, name and drawing the mechanism, defining the electronegativity and explaining the polarity in a carbon bromide bond. And then the nucleophilic substitution mechanism with excess ammonia, giving use of a mechanism product, which was a quaternary ammonium salt. So what is the use of that? And drawing its skeletal formula. So I believe you have to draw the skeletal formula of this guy right here, but feel free to check out that question if you're not too sure. This is definitely in the halogenoalkanes topic. Okay, it's to do with dipoles, all that good stuff, delta negative, delta positive. Try and learn this because it's good for understanding the mechanisms anyway, even if a question doesn't come up on it. Next up, you had to be able to draw the displayed formula this time and give the IUPAC name or something. And then we had a simple 1 mark, I think it was 1 or 2 marks, observation for an iodine reaction. Iodine? I said that weird. Iodine reaction. All right, cool. Isomerism, let's go. Only one question here. Now, the reason that I included this question specifically under its own topic of isomerism, which doesn't really exist, to be honest, it comes under Introduction to Organic Chemistry, is because I didn't really know where else to put it, okay? It was stating the type of structural isomerism shown by specific isomers. So I think it was like 4 isomers. I'm just going to call it A, B, C, and D. I'm not going to open the paper, but I'm pretty sure this was what it was, but feel free to check it out. And they were all different functional groups, and you just had to name the type of structural isomerism. Okay, so it was a bit of a weirdly placed one, but I put it here. Go over isomerism in general. It's always handy to understand. EZ and optical comes under stereoisomerism. Then you have a few different types of structural, like chain, position, functional group isomerism, stuff like that. Feel free to check that out, memorize that, revise it, all that good stuff. All right, NMR. Okay, NMR is a tough topic, but it does come up. Okay, it come up on every single paper. So I would personally recommend learning this, right? What do we have here? You have carbon NMR and proton NMR structure analysis and justification. Typical question here, okay? You're given some data, whether it's a spectra or a data table of number of peaks, splitting pattern, all this sort of stuff, and you have to justify a structure and problem solve, right? This is from 2017. Feel free to check that out. You had to identify the number of carbon-13 peaks and proton splitting pattern and draw a variety of isomers from NMR info. Okay, that's question 11, 2018. Next up here, you had to draw the structures of isomers based on protein and carbon NMR info. And then here you had to deduce the number of proton NMR peaks in a given structure. Then you had to draw the structure with given molecular formula, and you're given a number of proton NMR peaks, okay, including the splitting pattern information. That was from 2019. Let's move on to part 2 of NMR here. You had to explain the solvents and standards used in proton and carbon NMR. This was 6 mark level of response. I've answered this on my channel. Feel free to check it out. This one right here, you had to deduce the splitting pattern of a given molecule and suggest why it's difficult to predict a specific chemical shift given. So a specific one was given in the question. Feel free to check it out. And you had to deduce the structure of two isomers from a proton spec info. So I'm assuming this is some sort of data like splitting pattern, integration value, stuff like that. State the number of peaks you would see in the carbon NMR spec of a given molecule. Here we had to draw an isomer that has 3 carbon-13 NMR peaks, and this was an ether. Okay, so OO like that. So like that. Okay, cool. Proton NMR spec and data table, and you had to deduce the structure and explain the answer. Okay, cool. That's NMR done. Let's move on to organic analysis, which I said at the beginning, guys, also includes NMR. So I really hope you guys learn NMR. Let's move on to organic analysis. So test tube reactions right here. Normally, I would include test tube reactions under the specific functional group topic. So for example, Tollens reagent test tube reaction for aldehyde would be on the aldehydes and ketones topic. But this one, if I remember correctly, was like 6 marker and it was a bunch of different stuff. So I just chucked it under organic analysis. Next one here was IR and NMR spec analysis, very common where you're going to get a mixture of spectra and information from a variety of different stuff, and you have to analyze that and problem solve. Next one was a test tube reaction to distinguish alcohols, listing the reagent and observation. The reason that I included this here is because it also involved IR spec analysis. Okay, and this matching isomer structures to a spectra. So it also involves some isomer stuff as well. Okay, this was from 2019. Feel free to check that out. Next up here, you had to explain how 2 isomers can be distinguished based on their boiling points. So I suppose technically boiling points is to do with bonding, but I included it here because it also involved some extra stuff to do with NMR and infrared spec. So again, a bit of a synoptic combo right here. This was a 6 mark level of response. Next up, we had to state why you can distinguish specific molecules with mass spec using electrospray ionization. And I'm pretty sure the specific molecules is in reference to a actual specific molecule given to you in the question. Okay, not just generalized. All right, part 2 of organic analysis, we have infrared spec of carbon dioxide and explaining how carbon dioxide causes global warming. Next up, a test tube reaction observation of isomers with acidified potassium dichromate and Tollens reagent, describing how IR spec can be used to distinguish different isomers. State why the mass spec using electrospray ionization is not suitable to distinguish specific isomers given. If you see here, this was just asked on the previous slide right here. Okay, so just maybe that's a good one to learn as well. Then we have an IR spec analysis. Okay, question 7, 2021. All right, next up here, we have IR spec, carbon-13 spec, and proton NMR data table. This was another combo, right? And you had to deduce the structure, explain step by step for each data and spectra. Okay, so a typical 6 mark justification question that you will see. This was from 2022. I've done a breakdown of this video on my channel already, so feel free to check that out if you want. All right, organic synthesis, guys. I really hope this video is helping you out. We're getting through this. Question 1 here was providing structures, reagents, and conditions of multiple steps. So you're going to be given a reaction scheme here, always in these organic synths questions. All right. From methyl benzene to an amine, okay? So this is very common where you're given some sort of aromatic substance in the organic synthesis reaction scheme, just to confuse you a little bit. Next up, you have IUPAC naming, so nomenclature again, explaining nucleophile attack of halogenoalkanes, drawing displayed formula of compound Y in a reaction scheme, giving the structure of a compound based on empirical formula, and suggesting a reagent. Okay, so organic synth here, I included this here because it was just a variety of functional groups, and the examiner's report itself said that it was to do with organic synthesis, so that's what I put it under. Next up, you had to name the mechanism for a specific step of a reaction scheme. You had to complete the equation for a step of the reaction scheme. Complete reaction scheme. I've written it so many times. But that's pretty much the takeaway of this, right? Reaction scheme. Organic synth is all about reaction scheme. So what do we have here? Complete an equation, complete a mechanism, Reason why ethanol chloride is not used in industrial synthesis, okay? So just learn that if you can, to do with acyl chlorides, acid anhydrides, drawing a structure of a product, and completing another equation. So a lot of steps here, guys. A lot of steps in these organic synth questions. What do we have here? Part 2 of this. A variety of reagents, conditions, mechanisms, IUPAC naming, drawing repeating units from multiple steps of a reaction scheme. Okay, so the reason I didn't highlight everything here, but yeah, it's just a variety of everything chucked in. Just realize you do have to learn every single reagent, condition, mechanism, reaction, all that sort of stuff, right? A lot of catalysts involved as well, so just keep that in mind. Next up here from 2021, we had a variety of reactions, reagents, equations, mechanisms, both naming and outlining these mechanisms, okay, and suggesting why chemists aim to design synthesis methods with fewer steps and a higher percentage atom economy. So this was an interesting one. I hadn't seen this before. Naming reagents from multiple steps of a reaction, naming the mechanism of a specific step, naming the reagent, and provide the condition of a specific step. Okay, so as you can see here, I'm really hoping from organic synth, a ton of steps, just learn the mechanisms, reactions, conditions, all that sort of stuff, okay? Right, guys, polymers. So this is going to be mainly about condensation polymers, but you also have a bit of addition chucked in there as well. There's only two major questions here from paper 2017 and 2019, so let's check them out. Remember previously there was some alkene polymer stuff and stuff placed around, but for pure polymer questions, this is what we had. So you need to do the structure, repeating unit, type of polymerization, and a question to do with polymer biodegradability. This is pretty common, so just try and learn this if you can. This one here was drawing the structure of monomers. So just understand the difference between monomers and repeating units, okay? Try and get your head wrapped around that. Drawing skeletal formula of a monomer. So here you have to draw the monomer, the skeletal formula of a different monomer, and then IUPAC nomenclature of a monomer. So lots of monomers going on here. Drawing the repeating unit of a polymer, giving the reason for stereoisomerism, EZ, and explaining the biodegradability of polymers. So again, biodegradability, this was previously in 2019, so it could come up this time. You never know, in 2023. So I'd say biodegradability seems to be a common topic that they chuck in there at the end. So yeah, check these out if you're a bit confused about polymers, but let's move on. Right, this is the last topic, rate equations. This is hands down the king of paper 2, ironically, because it's a physical topic. It actually made me laugh when I saw all 3 of the highest marked topics were physical, but let's do this. So this question was a graphical question, okay? You had to draw the tangent to deduce the initial rate of reaction and calculate the initial rate from this graph, if I remember correctly. Next one, you had to calculate the rate constant and its units, okay? So just brush up on units here. And next one was an Arrhenius equation calculation. So I've done a few Arrhenius videos and I've gone into great detail on a graphical question for this topic and how you need to do the line of best fit, equating the Arrhenius equation to the y equals mx plus c expression of a straight line. So just try and learn that if you can. It does come up. So yeah, cool. Next one, completing a data table. So, you know, typical orders of reactants, concentration, stuff like that. We have to complete it. Calculating the rate constant K, including units. Okay, they love units in this topic, so wrap your head around how to solve units. Arrhenius equation graphical question. As I said, I've gone into this on my channel before. Completing initial rates table, determining the order of reactants, and calculating rate constant K, including units again. Another Arrhenius equation calculation, including units. So, okay, the main takeaway from rate equations, okay, get good at your calculations, get good at rearranging equations, specifically for this guy right here, because rearranging natural logarithms and stuff like that can be quite complicated for a lot of people. And also units, okay, so learn your units. Right, part 2 here. So this entire thing was from question 1 2020, okay? You had to determine the initial rate of reaction from a graph, including its units as well. You had to state the relationship between initial concentration of a given reactant and time. And you had to deduce the order of reaction. And this is from a data table, pretty typical here. If you've done some practice questions, you should be well aware of this. Completing a diagram of experiment showing collection of H2 gas, so a bit of a practical side of things here. deducing the effect on rate when concentrations of reactants are halved, given the rate equation. This should be a bracket here. Calculating the concentration of reactant given the rate constant and rate equation. So another calculation question. And defining the term overall order of reaction. All right, part 3 here. This is going to be my final part of the final topic. And then we'll go back to the summary table at the end and the chart so you can see what you need to focus on right at the end. Required practical 7. Okay, try and learn this if you can for paper 3 anyway, so it'll come in handy if it does pop up in paper 2. And it was just a variety of suggest questions, okay? And this was related to a specific practical method that they provided in the question. You had to plot some data from a table onto a graph, so some graphical stuff here, and you had to plot a line of best fit. And you had to explain how the graph drawn, so the graph that you drew, shows 0 order. So there's a variety of graphs that you have to kind of just memorize the structure of. So you can have your line of best fit or curve of best fit, and they're going to tell you a different order of reaction depending on the graph that you're looking at. So try and memorize those if you can. Question 10, 2021. Another Arrhenius equation calculation from a graph. And then this one right here, calculating K, including units again, okay, from a data table and rate equation. Calculating the initial rate of reaction, explaining a graph showing how 1/T varied with temperature, deducing the time taken for reaction from a graph, and then a final Arrhenius calculation to calculate activation energy. So I haven't mentioned this yet, but Arrhenius is normally to do with activation energy, okay? The main takeaway is energy units. I'm going to actually write this here because this is the end of the video pretty much. I'll go for a summary in a second. Joules to kilojoules. Okay, just please remember this, please. Okay, it comes up all the time. Examiners' reports often say that students messed it up, so just try and keep that in mind. I've done quite a few rate equation and Arrhenius videos on my channel, so feel free to check them out. Or any other YouTuber. Just do your best, revise. Take every opportunity you can to use resources, do past paper questions, fine-tune that revision, learn from your mistakes. So going back to this table, guys, do with it what you want. I would suggest focusing on the topics that have the highest paper frequency and the highest marks. 1,000,000% learn these 3. Okay, rate equations, amount of substance, chemical equilibria, Kc. They come up in pretty much every paper. Amount of substance feeds into other topics regarding physical chemistry right here. So do your best to learn these 3. That's where I would personally start if I had some excess time to focus on physical. In terms of organic, we can see here, organic synthesis, this is chunky. Carboxylic acids and derivatives, organic analysis, amino acids, NMR. Okay, these are all big, and amines. Okay, like I said, paper 2 is more difficult to focus on very specific topics because it's so broad. But hopefully this gives you better understanding of how many marks are allocated as well as the question frequency. Okay, so hopefully this helps you out. If you have any questions, let me know down below. I literally had hundreds of comments and DMs to get this video out. So it took me an insane amount of time to get this done, but hopefully you appreciate it. I really hope it helps you out. Okay, I wish I had a resource like this when I was doing my A-levels. I think it would just make things a lot easier. If you want to see one of these for paper 3, let me know. Okay, it might take a bit of time. Paper 3 is awkward, all right? Paper 3 is really awkward just because of the amount of multiple choice questions. But I'm going to do my best to get it out in the next few days. Again, if you did appreciate this, like the video. It really, really helps me out. Share it with your mates. Subscribe if you want. Best of luck with your revision and upcoming exams, guys. Until next time, peace.